Hi guys, good morning. Today we are going to begin our lecture in the respiratory system. So let me share the screen. Let's see here. Share screen. Okay. So here is the first slide. So in this one, we will start by talking about the respiratory tracts. So basically, we will talk about I plan to do this one. I plan to have two parts, two different lecture on this portion, respiratory system. The first one will be more like a introduction of this system, get to know each other, right? And then the next one we're talking about the function, like the major function of the respiratory system is breathing, right? Get in the air, and how do we use this air traveling from the lung into the tissue, and also how do our body regulate this function of the breathing. So that's the second part, but the first one we will start to kind of describe what are these. If you already have some background in the respiratory tracts anatomy before, or you learned about this system in other animals, for example, right? You can use this one to kind of refresh your memory, and it could get more about how this respiratory tracts um, works in human. So that's that. So the respiratory tract is a tract work together. It include different organs work together to control the breathing, to participate the breathing. So that's this one here. So this tract is a linear tract, and beginning in the nasal cavity, you can breathe in with the nose. That's the design of the nose to breathe in. Also, you can breathe into the mouth. Altogether, they will meet each other. These two are basically connect to each other in the pharynx. And the pharynx, the air will continue go into the larynx. Right here, larynx. This larynx is where we have this to generate the voice. So the air actually can be used to generate voice. That's what I'm doing right now. Then air will continue going into the trachea. The trachea has several segments right here. It's continuous, but you will see that this is not exact segment, but this is the cartilage. So cartilage will maintain this tube opening, otherwise it may collapse, right? If it's all soft, it may collapse. So the cartilage, you see this cartilage beginning in the larynx. These green thing are the cartilage, and then air will have two branches. Reach to the airway has two branches. These two branches are called the each one is called the bronchus, but the plural is bronchi. So the bronchi, we have left and the right, left and right bronchi, and then each one will go into the lung. So here is the lung. Lung is a collection of these bronchi and also the alveoli. So we will talk about that. So that's that. So this whole thing is the respiratory tracts. These tracts are generally separated to the upper respiratory tracts and the lower respiratory tract. So what's the difference? The vocal cord. So larynx, here we have the larynx, a place to produce sound. So sometimes students got confused by larynx, pharynx, and here we have the esophagus, right? So sometimes students got confused. The way I will, especially these two are so very similar. Larynx. So it's only the difference is the pharynx and larynx. The way I think about it is this, this is placed to make sound. So la 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 la, right? So larynx make more sense to me. So that's larynx. Here we have the vocal cord. Vocal cords separate, is a border separate the upper and the lower respiratory tract. So that's a quick question. Okay, what separate the upper and lower? What's the part of the upper? What are the parts of lower? Nasal cavity, pharynx are the upper. Trachea, bronchial, lung are the lower respiratory tracts. Now let's start by looking at the first one, the nasal cavity. So here is a nasal cavity, and this is the place that air start entering into our body. So what are the special things about the nose? First is that we have two nasal cavity. Here, right here, two nasal cavity. The second thing is that the nasal cavity is not smooth. Okay, inside of it, it actually has several folding. This is folding. Each side we have 3 foldings. Each one is called the conchi or called the turbinates. So that gives you the idea that when air going in, this folding increase the surface area, so air can be warm up. So this surface also reached with the blood circulation. The skin is so thin, the capillary circulation just right underneath the skin, and they can warm up this area. So this increase the chance that the air will get warm up. This one also provide the area to humidify the air. So our body want to have very homeostatic level, right? So, but air can be all very different. It could be the hot day, it could be the cold day, it could be the humid day, it could be the dry day. So, but the air going to our body, has to be very much the same. Otherwise, our body will reflect to it. But we don't want that. And the way to keep the air constant, have these products ready for our body to use, no matter where you are, is the one of the organ to work on that is the nasal cavity, the nose. So that's why we have this conchi, increased surface. The other thing is that after learning this, after know this, if you have something stuck in your nose, don't pick on it. I remember when I was a kid, I remember once I had a rice stuck into my nose. Very difficult to take it out. The rice grain, right, get stuck. Man, that's horrible. But you know what? Do I still remember that? I bet it's gone, right? I don't think it's still there, but don't pick on it. It will go out. It will go out eventually because here we have a lot of mucus, and it will wrap up these foreign particles, and then eventually it will go out. So that's that. So the function of the nasal cavity is to warm up the air, humidify the air. What else? What's the function of your nose? Smell, right? This is so important that especially this time that we have the COVID, one of the function deficit or the symptom of the COVID is loss of the smelling. And the smelling is here in the nose. That's because the COVID virus first goes through the air and attach on the nasal, and they start to attack on the, they will find a chance to attack the cells, although that the major receptor is the ACE2. Did we talk about it? If we're not, that's okay, So it will affect this nervous system. Our nose has the nervous system, has the sensory nerve to detect the smell. So that's another function, right? So that's the quick question here would be the nerve to detect the smell, to provide the sensory function of smell, is the olfactory nerve. This olfactory nerve will enter into the brain through the cranial nerve 1, CN1. So that's that. All right, so that's the nasal cavity. The next one, after that, you will go to the pharynx and then go to the larynx. Now go through this larynx, you will kind of like seeing this airway as the tree structure. So this is also called the respiratory tree. You can see it like this is big, like cartilage structure, right? And then here with the trachea. Trachea also has cartilage structure as well as smooth muscle. So this cartilage structure will keep the airway open. And the smooth muscle can conduct muscle contraction or dilation. It's very much like our blood vessel. So these smooth muscle are not controlled by our intention, right? We have three types of muscle. Skeletal muscle that is controlled by our intention. The other two are the smooth muscle and the cardiac muscle. Cardiac muscle and smooth muscle are the muscle not controlled by our intention. So these two are controlled by our autonomic nervous system, including the sympathetic and the parasympathetic. So in the cardiovascular system, we describe how this autonomic control the cardiac muscle, the heart, as well as the smooth muscle. So that's that. Here in the lung, it also controlled by the autonomic nervous system in the respiratory tracts. So wherever you see the smooth muscle, you directly think about the sympathetic and the parasympathetic, because that's the nervous system, the autonomic nervous system control our smooth muscle contraction. When they contract, the vessel become narrowing and reduce the diameter of the tube. If it relax, it opens up, right? So that's that. Now, how does the autonomic nervous system control the smooth muscle of the respiratory tree? It is that sympathetic will cause the major part is the bronchial and bronchial dilation. So that's that. So basically the way to think about it is that when we exercise, right, sympathetic kick in, our heart rate increase, heart contraction faster, so we have more blood to the muscle. We exercise, and now we also breathe in more. We will breathe in, the respiratory rate will increase, breathe in more. Now you need to have that airway opens up to take in all this air. So that's why the sympathetic will cause the bronchodilation. So that's the quick question here would be the anatomical part would be like, I will block this one, say, what's this one? Larynx. What is this one? Trachea. And what's this two? Bronchi, right? Or bronchus. You can remember it as a primary, secondary. I probably won't quiz you on the primary, secondary. There are three though. Primary, secondary, and the tertiary. After tertiary, it's called the bronchial. So 1, 2, 3, and then bronchial. And the bronchial, in the end of bronchial is the alveoli. So that's when we see this, and what enter into lung is the primary bronchus. This one going to the right lung, this one going to the left lung. So let's look at lung. All right. So before we look in the lung, let's kind of zoom out a little bit, review about this body cavity, because all these lungs are located in the cavity of the body. Here, body cavity, there are 1, 2, 3, 4 major body cavity in our body. Cranial cavity, we have this bone structure, skull, to house the brain and spinal cord. So that is the cranial cavity. We also have the thoracic cavity. So this is the region we have the lung and the heart. So that's the thoracic cavity. This one has the thoracic cavity. So it's a cavity. It must has the border wall, right? This structure to keep it as a cavity. The wall of this thoracic cavity or thoracic wall is formed by ribs, right? So we have these ribs from this cavity. Now, abdominal is the next one. So thoracic separate from the abdominal by the diaphragm. Diaphragm is the edge, right? And then here we have the pelvic cavity. So that's this cavity. Now, we have two lungs, left and right. Lungs are located in the thoracic cavity. So here we can also have quiz question that I block this one here, say ask you that what's this thing? What is this thing, right? What is this thing? What is this thing? So we have a left and right lung. All right. So that's easy, right? Now, another thing is that lung is not just uniformly two lungs. Lung has different lobe, okay? So in the right lung has 3 lobes. So basically the idea about the lobe is like this one here. So basically that when we have this branch, it will kind of like provide air into this lobe. And here is another like territory. Be more specific, we have different segment of the lung, but lung can be, and also not just that. These lobe are separate by physical separation. They are not just connected, but neutral as different by or provide different branches of the bronchial. They are physically separated. We will look at that. So right lung has 3 lobes, left lung has 2 lobes. So let's look at this lung here. So here is the 2 lung, right lung, left lung. 1, 2, 3 lobes in the right lung. You can see that they are separated. So you can see that here is these lungs are encapsulated by membrane. So there is a actually double layer of membrane covering it. It's like you have the plastic bag and you put your lung in there, right? Something like that. Or you have basically you wrap it. You know, we have the membrane to wrap it. This membrane actually goes through here and go in here and go in here. So they separate. They separate it. Not entirely separate, but they entering into it. So entering into it. It's still connected. It's not like totally separated. But this membrane go in here, and go in here, right? So here we have 3 lobes in the right lung, 2 lobes in the left lung. Again, here is trachea, 3 lobes, superior, middle, inferior. In the left, we have superior and inferior. Trachea, bronchial, bronchus, bronchi, you know, it's plural is bronchi. Primary, and then secondary, the secondary, and the tertiary. This tertiary is also called the segmental bronchial. So basically, this one can be considered as different segment. We have multiple segment, but we have total 5 lobe. Left lobe, 3 lobes in the left, right, 2 lobes in the left. Here is where we see this heart is located right here. Heart is more like in the center, but tend to be more like in the left side. So the right lung is larger, the left lung is a little bit smaller. This is called the cardiac notch. So that's this one. Heart is here, and this kind of squeeze the left lung a little bit. So we have this cardiac notch right here. So that's that. So this lung, as I mentioned earlier, that is wrapped by membrane. So let's look at this membrane. Here is the membrane. So this purple thing right here is a membrane, right? So you can see that this membrane is continuous, right here, right here, right here, right here. So it's continuous. And this membrane, because it's continuous, it forms a space. So this entering and inside here is space, we have the fluid. This fluid is very small, as you can imagine that this fluid is very little, but this fluid is required. It's not, otherwise it's gonna be too membrane, very dry, like attached to each other. But you need to know that the lung expand and expand and withdraw in a way, right? Expand and shrink, right? Expand, reduce, expand, suppress, right? All the time. So these two membranes will be kind of like pushed to each other all the time. So there will be a need to have this lubricated fluid inside of this space. Inside this space. So this space is called the pleural cavity here, pleural cavity or pleural space. And the membrane is called the pleura. So here, this membrane is called the pleura. This pleura can be divided into two pleura, even though it's continuous, as we see earlier, is continuous. But it can be divided into two pleura. One is one attached to the lung, like this one here. This one is called the visceral pleura. This visceral pleura is attached to the lung, so it's more thin. It's a thinner, more delicate. And you can see that the one to form the fissure or to separate lobes of lung is the visceral pleura. So this visceral pleura entering physically separate the right lung into the superior, middle, and inferior lobe. So this is visceral pleura. Visceral pleura is the one, the membrane attached to lung. And then in this location is called the hilum. Hilum is where we have this bronchus entering into the lung. And in this hilum, this visceral pleura meet the parietal pleura. So the outside, this one is called the parietal pleura. So meet the parietal pleura. Parietal pleura interface with the muscle and the ribs right here. So muscle ribs right here. So that is the parietal pleura. So that's that. So that's these two pleura. The quiz question would be is the what is the membrane of the pleural cavity? The pleural cavity, the membrane of the pleural cavity include the visceral pleura and the parietal pleura. Which one attached to the lung? That's visceral pleura. Which one form the fissure of the lung? This is the fissure, right? This is the fissure, the lining fissure of the lung that separate the lobes of the lung. That is the visceral pleura. This is the diaphragm recess. That is the the parietal pleura extend because here is diaphragm, so it's kind of like go further like into this area, and this area is the region we can be, it will be the spot that if we need to collect fluid, sometimes we need to collect fluid from the visceral, sorry, from the pleural cavity.
I got an idea.
Hold on.
What?
All right. So that's gonna be the quiz question. Of course, we can have quiz question like I can block this area and ask you what's this thing? Visceral, what's this thing? Parietal, what's this thing? What's this space? This is fissure, right? And the space here inside of this one is the visceral cavity. Sorry, pleural cavity. Pleural cavity doesn't show here. Pleural cavity, that is inside this one here. That's that. All right, so this is another picture showing you the pleural cavity, right? Wrapping around the lung. This one is not as good as this one because this one show you the fissure. This one kind of ignore that fissure part. However, I like this one. I like to still put this one here because it shows you that this membrane protection is a common like feature in the thoracic cavity. So these two major organs, lung and heart, are two major organs in the thoracic cavity right here. This is the thoracic cavity. Here we have lung and the heart. With these two very important organs in our body are all wrapped by individual membranes. So here, each lung is wrapped by its individual membrane, actually 2 layers of membrane, and the inside of this one is the 2 layer but continuous, right? 2 layer but continuous. Inside of this is pleural cavity. Right lung has it, left lung has it, also the lung, also the heart. Heart also is protected by the pericardium, also called the pericardial space right here, pericardial space. Pericardial space contains the fluid, is formed by this membrane. This is also a continuous but double layer membrane. So in the one near the heart is called the visceral pericardial. The one outside is the parietal. So the naming is the same. Visceral is one near the organ. Parietal is the more like outside part. So that's that. All right. So this just summarized what's that, and left and right pleural cavities are independent. They do not connect to each other. Each one wrapped around each lung. Lung is not in that cavity, right? That cavity is a continuous membrane, and that is surrounded by surrounding the lung. Left pleural cavity is smaller because left lung is smaller because there is a heart, and the smaller part is called the cardiac notch right here, right? This is the cardiac notch. So left side is smaller, and so that's that. Here is two. Basically, what we just say right here is just I just put the text here so you can know. The pleural space is, or pleural cavity is the space between visceral pleura and parietal pleura. Parietal pleura is thicker. That's one more durable, attached to the thoracic wall. And the mediastinum. Mediastinum is the part that's right here. That basically is this region. If we see this one, this is the mediastinum. That is a space called the mediastinum. And the visceral pleura is the one attached to the lung. Both membrane meet each other, are continuous at the location of the hilum, right? So that's right here, hilum or hilum, right? So visceral, parietal are continuous in the location of the hilum. So that's that. All right. I think this one is continuous. Visceral pleura is directly attached to the thinner, and the feature is formed by the visceral pleura, and this visceral pleura continue with parietal pleura in the area of hilum. So I think this is just a repeated slice from the previous one. All right, so that's that. Lung can also be separate, divided into different segments. That segment is each unit of this segment is based on the segmental bronchi. Segmental bronchi is the tertiary bronchus. So this primary right here, secondary, and the tertiary. Each one is in that territory. Within that territory is a segment. So this bronchi bronchus is also called the segmental bronchus. So this segment is called the bronchopulmonary segment. Bronchopulmonary segment. And after that, this segment, this bronchial will connect with the bronchial. Bronchial will then connect with the alveoli. Now, what is the importance of this bronchopulmonary segment? So the first is that why is that important? It's because that we can, if there's any infection or the injury, a surgeon can carefully remove this segment. And by doing so, they basically just cut the branch out. So that portion is a bad, like a branch. We can cut it out and still remain the entire lung healthy. Okay, so that is the purpose. And by doing so, we can remove. This is the smallest unit that we can remove from the lung while keeping the entire the remaining portion of lung healthy. So that's that. So each of these bronchopulmonary segment is separated by its tertiary bronchus. That's that. Now the next one is the very end is the alveoli. Single noun is the alveolus. The plural is alveoli. Now this alveoli is the place we have the gas exchange. So throughout this area, we basically, a lot of this bronchial has this smooth muscle. So it's the cell wall is the tubule wall is very thick. It cannot allow substance exchange. It's very much like artery, veins, and the capillary, right? Capillary has only single layer of the endothelium cells. Same thing here with the alveoli. It only has single layer of the, not the endothelium, but it's called the epithelium cell. Epithelial cell. epithelial cells. So that is the alveoli. Here in the alveoli, we have this single layer of the cell wrapping around to form this. And the reason we have a lot of this instead of the single one is that we need to increase the surface area, so we have more chance to get the substance exchange. If it's only big one, then the inside air doesn't have the chance to get absorbed by our tissue. So we need to have this very small one. Now each one are also wrapped around the capillary. The capillary will connect with the vein, go back to the heart, and this one will be the oxygenized. So that's that. So the end of the bronchial is called the respiratory. So this is the respiratory bronchial, and it's the final branches of the respiratory tree. The alveolus is the hollow cavity and the basic units of the ventilation. So each one conduct the gas exchange. Gas will pick up by O2. CO2 will be released into the alveoli and breathe it out. O2 will pick up by the alveoli and pick up by the blood vessel. The wall of this alveolus is formed by the single layer of the epithelial cell. So let's look at this one and surrounded by the capillary. So let's look. So that is the picture of each of these alveolus. So you can see that each one is an epithelium cell. We also have some macrophage here. So you need to know that our body, this is a region, is interface between body and the outside world. So the chance to receive the infection, the bacteria, virus is high in this area. So we have the macrophage here to conduct the first line of the body defense. Here between the alveoli, we have the capillary. So here is the capillary endothelium cell of the capillary. So in this region, for example, in this region, we have the air and we have the capillary. So we have the gas exchange. O2 breathed in will get diffused. O2 is gas, so it can diffuse across the membrane into the capillary, pick up by the red blood cells. CO2 is also gas, so they can diffuse across the membrane from the blood into the alveoli. So when we exhale, it will get breathed out. When we inhale, O2 part of the air, 20% of the air is the O2, will get diffused in here and diffused into the capillary. See what we have here. In the alveoli, there are two types of the epithelium cell, type 1, type 2. Type 1 is a common one, type 2 is more rare. It's not, the major one is type 1. And what else? Red blood cells. Here is type 1. This is the alveoli. There are some pores to maintain the air pressure. This is the entire, so this membrane is called the respiratory membrane that present the hurdle of the gas to transport from two different media, from the water, from the blood into the air, or from the air into the blood. So this membrane, including the alveolar epithelium, the basement membrane of tissue, and the capillary endothelium. So basically, that's respiratory membrane. Include these. So that's that.
Are you good?
Now, in the alveolus, alveolus is the space filled with the air, but in the surface of this alveolus, all right, is it dry or is it wet? It is wet, so it cannot be totally dry. Then the question is that how can we maintain it's wet in the surface? If we simply just drop the water in the alveolus, the water will form a droplet, just like water here, right? Water will form droplet. Then we will see something that a big chunk of water inside of the alveolus, and it's not good because then there will kind of like it's a bag of the water, but not an air bag, right? So how can we keep the surface wet, but while we have the fluids there? The tricky part, the key here is the chemical or protein called surfactant. So surfactant is produced from the type 2 alveolar cells. And so we have type 1, type 2. Type 2 is one to produce this surfactant. And the function of the surfactant is to reduce the surface tension. So here, why do this droplet form a droplet? It's because of the surface tension. They form this droplet. And the surfactant to reduce that surface tension. Surface doesn't really have the tension to hold it together. It will relax. And then it can laying on the surface of the alveoli. So that's that. All right, so that is that. I just paused a little bit so I can reform this slides here. It was kind of like covered by the picture, so I did some correction there. All right, so that is that. So we have the basic idea about these respiratory tracts. Now, the next step is how do we perform the breathing? How our body perform the breathing? Now, when we think about the breathing, basically, we need to expand the lung, right? In order to breathe in air. But one thing about the lung is that lung doesn't have cannot expand. It doesn't have, it's not like heart. Heart contract. We have the heart muscle. It's called the cardiomyocyte or cardiac muscle cells. It contract, so heart can squeeze to the blood or expand, relax, and blood coming in. So that's the heart. But how about lung? Does lung squeeze or relax? No, lung itself does not do it. Lung basically is formed by this alveoli, and they don't have the muscle to squeeze them. All right. So how does lung do it? The lung do it not because of the lung itself. It's because of the thoracic cavity. So here is the situation. Lung does not inflating themselves. Lung expansion is called the inhalation breathe in, is by moving the thoracic cavity. So the idea is that here, we breathe in, right? This is the lung. The way we breathe in is that we expand these by moving our chest, expand this cavity, then the air will go in. It's very much similar like how you draw water using a syringe. So the way you do it is to you expand this space. This will be your, when you expand it, increase this space, the water will draw in. So no matter how you are laying down, standing up, no matter what, you expand this thoracic cavity, it will increase the low pressure because you expand, you increase space. Then the extra space will make these inside of this space become more like with less pressure. So that's why it's negative here, less pressure. Then the air will go in. So let's look at what is this. How does we conduct it? How do we expand the thoracic cavity? So thoracic cavity is the place, it's one of the body cavity. That is a cavity host the heart, the lung, and the gland. So we kind of talked about it earlier here, right? This is thoracic cavity, separate from the abdomen by the diaphragm. So that's thoracic cavity. So here we have in this thoracic cavity, the thoracic cavity is inside of this bone structure called the ribs. We will look at it again. It's separate from the abdomen by the diaphragm. Inside of it, we have the right lung, the left lung. We have the heart. Heart is wrapped by the pericardium. It's cut. So this is another membrane space to protect the lung. This is the epic of the lung. This is the vessel, right? This is the aortic artery. So that's what we have learned. So that's everything here. All right, so that's that. And then kind of like give you a quick review of our body parts. This is the thorax, and that's why we call this one is a thoracic cavity. Thorax is between the neck and the abdomen. This is abdominal cavity, and the head, upper limbs, lower limbs. So just different parts, but I just give you an quick overview here. Now, thorax include inside here is a place we have this thoracic cavity. And thoracic cavity is formed by the thoracic walls. So here we have the thoracic wall to form this cavity, right? Now, what is this wall? This is a wall that will expand and suppress, expand in order to cause the inhalation. Now, what is this wall? This wall is formed by a lot of the bone. It's just like cervical cavity is formed by our skull. This is very easily understandable. Lung or the thoracic cavity is same thing, formed by this bone. This bone is there are some important bone. Basically, three major one, but several others. The major one including these ribs. So that is very important. You need to know that we have 12 ribs, 12 pairs of ribs. 12 pairs of ribs, each one connect with the spine or the vertebra. This is the spine. Spine is a series of the vertebrae. So here is each one of these is a vertebrae. the ribs, because we have 12 ribs, we have 12 segments of this spine connect with the ribs. And these will make this portion of the spine called the thoracic vertebrae. So we have total of 12 thoracic vertebrae. So we have the ribs, 12 pairs of ribs. We have the 12 thoracic spine. In the front, we have the central portion. This is called the sternum. So that's a three major part of the bone structure of the thoracic wall. 12 ribs, 1, 2, 3, 4, 5, 6, 7. Now, 1 to 7 connect with the sternum. 8, 9, 10 connect with each other, but they don't connect with the sternum. They basically connect with the 7. 11 and 12 does not meet each other, does not form the closure in the front. They only form the closure in the back, but not in the front. So that's this 12 pair. When they connect with the sternum, they connect with, not directly, they have this cartilage. I'm not saying here, but that is the cartilage right here, costal cartilage. So this is the cartilage. So it's the joint. So it allows some flexibility of these long ribs to move. So that's that. Sternum has different portion. The manubrium part. This is the angle. This is the body, and here is the exiphoid process of the sternum. So just some more detail about that. So sternum, spines, thoracic vertebra, 12 pair of the ribs. So that's a major one. And what else? Two other very important part to form this thoracic wall is the clavicle. So clavicle is this bone on our shoulder right here. And then in the back, we have this bone is called the scapula. So scapula right here. Clavicle connect with this scomium, and this is the scapula. Scapula has several surface. Here we see this is the coracoid process. Here is the glenoid cavity right here. So that's major part of the bone structure of the thoracic wall. So that's that. What else? I think that's it. Thorax, yes. All right. So this thoracic wall is the major part are these 12 pairs of ribs. These ribs also form this rib cage. These are important to know that with these 12, only 10 has a closure into the front. The total 12, the remaining 2, number 11 and 12, does not form the closure to the front. They only connect in the back. So because we have 12 pair of ribs, we have the 12 thoracic vertebra. In this 10, which close in the front, this 10, 7 connect with the sternum directly. The other 3, the remaining 3, 8, 9, 10, merge together in the front. So that's that. So that's that. 8, 9, 10 merge. Only 1 to 7 connect with sternum. 11 and 12 does not close in the front. So that's that. When they connect with the front, they connect through the costal cartilage. So a lot of quiz question here, all right? Basically 7, 3, and 12. So that's probably, you know 12, right? 12 is 10 are connected, but not, and the 7 are connected with sternum. The other 3, 9, 10, 8, 9, 10 merge. 11, 12 does not connect in the front. So that's that. We kind of go over this already in the previous slides. Just give you another picture to show you in the bone structure of the thorax. The thoracic cage, total 12 pairs of ribs. The 11 and 12 does not close to the front. These 12 connect with the spine, including the T1 to T12. So that's the thoracic vertebral. In the back, we have this scapula. Scapula, it doesn't show here. Scapula. Sorry, scapula right here. Scapula. So that is a scapula. So this scapula in the front, we talk about this one here, clavicle. Clavicle connect with the acromion to the spine. Don't confuse the spine with the spine. This is just the spine of the scapula. In the front, we have the sternum. Sternum has manubrium portion, the body portion. This is the angle. This is the xiphoid process. That's that. In the scapula, we have this is the carotid process. We have this glenoid fossa. And the ribs connect with the sternum via the costal cartilage. So that's everything here. So talking about this thoracic vertebra, does one connect with the ribs? How many pairs of ribs do we have? 12. Then how many thoracic vertebrae? We do have 12. So we have T1 to T12 thoracic vertebrae. That is the connection, that is the segment between the cervical vertebrae and then the lumbar vertebrae. So that's that. Now we have all this. We know the bone structure of our thorax. We know the wall of the thoracic cavity. Now this question is that how do we use this to conduct breathing? All right. So breathing, we do breathe every day. So this is not something that totally out of the world, right? We basically can test it ourselves. That's how we breathe. Breathe can be viewed as different modes. The generally two major mode is these two. One is called the quiet breath or called the normal breath. The other one is called the forced breath or heavy breath, though it's depending on the literature. Basically, these two. And the more important is how do we distinguish these two? The quiet breath, so breath basically include two processes. One is inhalation, the other one is exhalation. Now, the quiet breath, this is also called the eupnea. This eupnea when we inhale, we work on it. We need to expand. Two parts of the muscle are used. One is the diaphragm. Diaphragm, we will lower it in order to expand our, here is our cavity, right? Our cavity, we will lower the diaphragm so it can expand it, become larger. Then the lung will expand and the air will go in to fill in that space, right? So that's what we do, the diaphragm. And also, it really depends on, you can breathe in only the diaphragm, but also we can breathe in with, in addition to that, is the intercostal. This is a rib. So not just the diaphragm, but the rib. The rib will lift up a little bit, not a lot, but lift up a little bit. So that is the intercostal. This is called the external intercostal muscle. So that's that. So we make effort to breathe in air. While we breathe out, we just relax this muscle. We relax the diaphragm, relax the external intercostal muscle. Then everything, we expand it. When we don't make any effort, it squeeze back, kind of recoil back, and then we breathe out. So that's the while breathing. As for the forced breathing, we will use the same muscle. But in addition to this muscle, we will also use some other muscle to conduct the forced breathing. So that's the accessory muscle. We will talk about that. So just here, what you need to know is that we have two major modes of the breathing. While breathing, we make effort to the inhalation, but not exhalation. For the forced breathing, we make effort on both inhalation and exhalation. So the quiet breathing is an active inhalation. We make effort to it. Passive exhalation, just relax. The forced breathing, we make effort, active inhalation, and active exhalation. So this is a picture showing you the normal breathing or eupnea. U means normal. What's the other ones? Sorry. Hypermnia means larger, right? Eupnea, so we breathe in by inhalation. This is an active one. We need to make effort to part the muscle. So this is the quiz question. Are the diaphragm contraction and external intercostal muscle contraction lift up the lung, pull down the diaphragm. When we relax, the thoracic cavity reduced and we breathe it out. So that's that. All right, so this just summarize what we just talked about: inhalation, contract the diaphragm, as well as the external intercostal muscle. And when we relax, we exhale the air. So the idea is that here is how the pleural space are participated in this process. Basically, when we expand, when our muscle, when our thoracic cavity expand, we kind of opens up more space of these pleural space that will make this area become negative, and then it will pull this lung to expand. So that's that. The air coming in, atmosphere pressure is 760, and when we expand our thoracic cavity, we produce a negative intrapleural pressure to about -4. So that will, and this is, we hold it. So the way to compare to the lung and this space is that this is 0, right? And or the 760, now this one is 760 -4, so this will, the lung will expand. So very much like this idea. So basically that we increase the space in the thoracic cavity. And then the next thing is that the air or the water will follow that low pressure, negative pressure, and we get in the air. So you probably hear this from the other lecture, that that's how the pleural space, not just the space where it kind of protect our lung, it create that kind of the negative pressure to suck the air into our lung. That's that. What's that? What's that? Okay, so that's down here. Okay, all right. So that's the normal breathing. Now, the next one is the forced breathing. Forced breathing will use the external intercostal muscle and the diaphragm. In addition to that, you also use some accessory muscle. Now, accessory muscle for the inhalation are 3 groups of muscle. So that's important to know. These are the 3. So this is kind of important that we know this muscle, because that in the future that you, even not in the future, you know, in the case that you have, you need to work on your own breath. You need to train your breath. Say you want to train your performance in the so we know this muscle, so you need to work on your muscle for the breathing. These are the group muscle you work, like just like every other workout, that you have specific muscle you need to work on, right? You don't just labor, right? You work on your muscle to enhance the performance. And this forced breathing are especially important in the exercising. So if you have stronger muscle in this part, your breathing will be improved and your performance will be improved too. So what are these 3 group of muscle work on the forced breathing in the inhalation? So these 3 are the sternocleidomastoid muscle right here. So these are the sternocleidomastoid muscle. So just by the name, you know that it is related to 3 bones. One is the sternum, one is the clavicle, one is the mastoid. So that's the 3 like ends of this muscle. The second one is the serratus anterior muscle. So the serratus anterior muscle is a group muscle, connect the ribs right here. So this one, serratus anterior muscle, connect the ribs to the scapula. We'll talk about that. And the other one is the scalene. Scalene muscle is part of the neck muscle. Connect the rib 1 and 2 with the cervical vertebrae. So we will look into that. So that's the 3 group of muscle. So let's start by looking at the first one, sternocleidomastoid muscle right here. That is this one. We have 2 group of that connect with the sternal right here, sternal. So its origin from the mastoid. This is the mastoid process of the temporal bone. And from there is reached to the sternum. So that's the sternomastoid part, and also to the clavicle right here. So that's that. So that's this muscle. This muscle is very obvious when we face the front. It's a little bit twisted, but if we turn, it will be showing up. Or like this one here. It's right here. So that's right here. That's right here, right? Sternocleidomastoid. So what does it do? Of course, it's important to rotate our head. But as for breathing, it will lift up our sternum and our clavicle, so it expands our lung better. So that's that. So this is the clavicle, scapula. That's the one we are going to talk later. It's also called the shoulder blade, sternum. Clavicle is also called the collarbone. So that's that. All right. The next one is the serratus anterior muscle. So this one is the muscle originated from the ribs, rib 1 to ribs 8. And from there, it go along with the ribs toward the back, toward the middle border of the scapula. So this is scapula. So they reach to the middle border. This is middle border of the scapula. So what does it do? When they contract, they will pull this back wing, right? This shoulder bone sliding toward the front. And so it basically opens up your back a little bit more. And by doing so, you expand, you increase the capacity that your rib cage can expand. So that's that. So you pull these two scapula toward the front and opens up space for your inhalation. This muscle is also important for our arm movement. So for people, so for say for if you're training, right? If you're training, this is a muscle, especially for the boxing. If you swing a fist, you basically pull this scapula toward the front. You need to make it very strong and fast. And if you want to do that, this is the muscle that you work on, the serratus, anterior serratus muscle, serratus anterior muscle. So that's that. The third one is the scaling muscle. The scaling muscle is part of neck muscle. We have 3 pairs of it, each in each side. Three pairs, 3 in each side. They origin from the cerebral vertebrae C2 to C7. They are initiated from the transverse process of this vertebrae. So this is the vertebrae total. We have 7, 1, 2, 3, 4, 5, 7. 2 to 7 is the one to find this muscle, and they they enter into, or they connect into the rib 1 and the rib 2. So that. So this muscle, what's the function of this muscle? This muscle in the neck, so it controls our head movement. When we breathe, it lifts up our ribs. So that's that. Increase the thoracic cavity. So that's these 3 group muscle. All right. So as for the exhalation or expiration, The other two muscles that we will use, one is the abdominal wall. You breathe out very hardly, not just the diaphragm, but also the muscle, right? Diaphragm relax. You don't really, when you breathe out, you don't contract your diaphragm. We also use the intercostal muscle, but this one is the internal intercostal muscle to cause the forced breath exhalation or expiration. That's that. Now we know everything about the breathing. We know the structure. We know how muscle move the way the breathing. The next one is that how do we breathe? Right? That's a question. You have this one in your body. You have your cousin, you have your mother, you have your parents, right? They all have this, but how do we breathe? How do each one breathe? If you see a patient, how do you evaluate their breath? Just let them breathe, and we measure it. Breathe in, breathe out, breathe in, breathe out, right? That's how we breathe. And we can measure the amount each time you breathe in, breathe out. And also the speed. It's just like your heart, right? Contraction, eject the blood. And then how fast is the heart rate? Breathe the same thing. Each time we breathe in, breathe out, that's the amount. And that amount is called the tidal volume. That's right here. So the major function of the breathing is quantified by our respiration pattern. And this respiratory pattern can be quantified as the speed of rate, respiratory rate, how much time you breathe each minute, as well as the amount of breathing each time. So the amount of breathing each time is called the tidal volume, just like tidal wave, in and out, in and out. So the amount you breathe in, which will be equal to the amount you breathe out, because we don't accumulate, right? We breathe in, breathe out. So the amount of breathe in equal to amount of breathe out, and that is the tidal volume. And also the speed. And we can also have an equation called the minute ventilation. So we can increase the speed or increase the amount in order to have higher ventilation or higher minute ventilation. The minute ventilation equal to the tidal volume times the respiratory rate. So that is an important equation, you know, right? How do we know this? How do we measure it? The way to measure it is to use the spirometry. So this one is a picture showing how do we do the spirometry. It basically has it's very much like you blow this the toy, right? You blow it, it will turn. And we have similar structure, similar design here. You blow it, it will turn, and it will be recorded. Breathe in, breathe out, breathe in, breathe out. So by doing so, we can quantify the amount of the air you breathe in and breathe out, breathe in, breathe out, inhalation, exhalation. So that's that. Using this spirometry, we can basically quantify several important numbers. The major one would be the tidal volume. As I told you earlier, during the quiet breath, you will breathe in, breathe out, breathe in, breathe out. And we can have the time. So we know that the respiratory rate, tidal volume times respiratory rate is the minute ventilation. So that's right here, minute ventilation. In addition to that, we can also push the limit, right? We can force breathe in. So we can say this is the express. So this is the zero volume. There are some volume that we don't change, like the air tract. So when we breathe out, we don't squeeze everything, right? So that space is about 1,000 lung, 1,000 liter, is always there. It doesn't really change. But when we breathe, we don't use all our capacity. But when we breathe in here, so we can expand a lot more. So beginning in here, we can breathe in, breathe out. So it's about like 500 milliliter each time, but we can force to breathe in more. So this is called the inspiratory reserved volume. That's the amount, extra amount that we can breathe in. Or we can breathe out furthermore as the expiratory reserve volume right here. But the major part is the tidal volume. So tidal volume. So this is the major one. But by doing so, we can kind of know the total capacity of the lung, total capacity of the lung. That includes the vital capacity. That's one, functional, as well as the residual volume. So that's the using this spirometry, we can quantify different aspects of our lung function. We can also, so tidal volume is the major one. That tidal volume times the respiratory rate is the minute ventilation. That's the major one. That's some other important one are the inspiratory reserved volume as well as the expiratory reserved volume. Also, the residual volume is the one that's important to know. So tidal volume, vital capacity is everything, everything that functional, including these three. Tidal capacity equal the inspiratory reserve volume, tidal volume, and expiratory reserve volume. So that's that. Another thing that we can also measure is the more dynamic. That is that we can ask the person to forcefully breathe out. So we basically hold it and breathe out, right? So by doing so, we have a trajectory. So this is time when we hold it, breathe in, all you can do, right? Breathe out, all right? So that will provide several important measures. Say you breathe in, you hold all the air, you breathe out. So to the end, you will reach to the total capacity. So this is the forced vital capacity. That is basically total capacity. That's right here, total. You breathe out, so the volume breathes out the amount, and the end you get it to the plateau, right? You cannot breathe out anymore, and you probably hold it, but not increase it anymore. So that's that. So that gives us two important measures. One is the total capacity. So that basically is this one, total vital capacity, right? Vital capacity. That's one that you can breathe in to breathe out, the total amount. This one is also called the force. In this graph, we call it a forced vital capacity because this is basically it's a vital capacity is forced. So you can call this one as forced vital capacity because this one has to breathe in all you can and breathe out all you can. So that's the vital capacity, also the forced vital capacity. So you can first get that, right? The second is that how fast you blow out. When you blow out fast, so the way we measure it, we call it forced expiratory volume 1. This one is the second one here. So that's the first second. So you forcefully breathe out. The first second is right here. So that's that. So we can, if your airway is narrowing, but your lung is okay, then you can to the normal forced vital capacity. Everything will get squeezed out, but slower. So your FEV1 will be low. because the airway is narrowing, right? But if your airway is open, right, as everybody else, but your lung capacity is smaller. So in the very first minutes, you can breathe fast as everybody else. So you will have the normal FEV1, but the total amount you can breathe out is limited. Then you will have the lower forced vital capacity. And by reading these FVC and FEV1, we can diagnose the lung disease into two different types of lung disease. One is called the restrictive pulmonary disease. That is, lung is restrained, that the lung capacity is limited, or the obstructive, that is the airway. If the airway or the trachea is narrowing or the bronchi is narrowing, then the first second will not be able to breathe out the amount of air like the normal people. So that's that. So these two numbers are in a way important in the clinical setting because we can use the FVC, low FVC, and or low FEV1 to kind of differentiate, diagnose these two types of the lung disease. We will talk about the lung disease in our next portion, but at this one, we know that how can we measure the respiratory, how do we measure the spirometry, and by using these to quantify different ventilation parameters, as well as these two important parameters clinically relevant to diagnose the lung disease. So that's that. All right. Hope this helps you to kind of overview the entire respiratory system. And next one we will talk about, and another one we will talk about more like gas exchange and the regulation or the function of the lung, right? Let me know if you have any questions